Okay, here's the last section of this chapter. We're going to just go through a very brief overview of organic compounds. When we say that something is an organic compound, those will be the major components of anything living, okay? They're also the main component of a lot of fuels. So if you have gas, oil, natural gas, things like that, and the main component in pharmaceuticals, right? Organic and inorganic compounds do have different properties. I've listed out some of the main differences here, where you have organic compounds. They're easily decomposed, so they're a little more fragile. And we could not initially make organic compounds in the lab. That's a more recent development historically. We've been doing it for a while now, but in relation to the entire existence of chemistry, it's pretty recent. Inorganic compounds, on the other hand, are very difficult to decompose, but they're very easy to create in a lab. When we think about organic chemistry and organic compounds, the main element that we're going to focus on is carbon, okay? Organic compounds are usually made up of carbon and hydrogen, and then a few other elements. Okay, but the carbon and the hydrogen, those are the big things. Those are the big focuses. Carbon in general bonds covalently. So it shares electrons. This has to do with the fact that it has the 4 valence electrons in its shell. So it's a lot more energy efficient for it to be covalently bonding instead of ionic bonding. When carbon does bond covalently, it does so by creating 4 bonds, okay? These bonds don't necessarily have to be 4 single bonds. They can be, but they can also do any kind of combination. So you might have 2 double bonds, a triple bond, and a single bond, a double bond, and 2 single bonds. As long as the total number of bonds is equal to the 4 covalent bonds, carbon's pretty happy. And carbon can form extremely long chains of carbon atoms. They can be straight chains, they can be branched chains, and they can be rings. It's almost limitless in the shape and type of compounds it can form. This is a little breakdown of what you're looking at in terms of carbon compounds. You start looking and you're like, all right, I've got inorganic compounds and I've got organic compounds. And we're going to focus in on the organic compounds over here. Once you've decided that you have an organic compound, then you're either talking about having a hydrocarbon or a functionalized hydrocarbon. All right, so a hydrocarbon, like the name implies, is something that contains carbon and hydrogen, right? And a functionalized hydrocarbon isn't a lot different. It just happens to contain additional functional groups attached to it. Standard hydrocarbons are what make up most fuels, right? So all of these are examples of standard hydrocarbons. When we name hydrocarbons, we name them based off of the number of carbons present and the types of bonds that are present. All right. So if, for example, you have a hydrocarbon and it only has single bonds present, that hydrocarbon is called an alkane. Okay. That has an A-N-E ending, an alkane. There is a general formula for all alkanes, and that will tell you the number of carbons in relation to the number of hydrogens. So for every 1 carbon, we have 2 times the number of carbons plus 2 hydrogens. You're like, Lauren, what does that mean? Well, I want you to look at this example here. We have CH4, that's methane. So I'm going to show you this real quick. Okay. So I told you that this is a standard hydrocarbon, CH4. This means that I have 1 carbon and I have 4 hydrogens. So If I have CnH2n plus 2, look what happens when I fill in the blanks here. Carbon 1, H 2 times 1 plus 2. That equals 4. So the formula for my hydrocarbon is CH4. Okay, so every alkane will have the same kind of relationship between the carbon and the hydrogen, that 2n plus 2. All right, an alkene, on the other hand, will have double bonds in it. Okay, so you see that ene ending, that indicates that you have an alkene. Okay, the double bonds. All right, the general formula for an alkene is a little bit different. It's CnH2n. All right, and look at the example here. So this is called ethene, and you know it's an alkene right away because it has the ene ending. Now the formula for ethene is C2H4. Now look at its relationship when you bring it back to the general formula. Our N value is 2. 2 times 2 is 4. So C2H4. Okay, and the structural formula of the ethene is like this. So you see that nice double bond right here. The last type of hydrocarbon is what's called an alkyne. And an alkyne contains triple bonds. Right? The formula for an alkyne is CnH2n minus 2. And our example here will be ethine. And we know that it's an alkyne because it has a YNE ending. It must have a triple bond in it. So let's look at the formula for ethine and relate it over here to the general formula. If our C value is 2, then H is 2 times 2 minus 2, or 4 minus 2, which will just give us 2. So C2H2 is the formula for ethine. Okay, now we can tell the types of bonds in the compound from the ending, right? But we can tell how many carbons are in the compound based on the prefix. Okay, so we've already looked at the suffix part of that. But what we want to look at next is this part here. The base name comes from the number of carbons present. Okay, this unfortunately is going to require a little more memorization because you're going to have to know the prefixes for each of the organic compounds. Right? But you only have to know the 10 of them, and a lot of them are very straightforward. Okay, it gets very repetitive. You know, there's only so many ways that you can have a prefix for the number 5. So get used to those. So our base name, let's get a little drawing thing back. So this right here is going to be the prefix, and then this right here is going to be the type of bond. Okay, so this is the number of carbons. This is single, double, or triple bonds. And that's how you're going to name your hydrocarbons. Okay, that's until you get a hydrocarbon that has a functional group attached to it. Then we have to do one more step. All right, but for now, try this out and use those generalized formulas to try to answer this question. What would the formula be for an alkene that has 2 carbon atoms? Right? The formula for alkene is CnH2n. So what would the overall formula be? What would the overall formula be for an alkane that has 22 hydrogen atoms? If you know that the formula for an alkane, let me write it on the board over here. Okay, we know that the formula for an alkane is CnH2n N H 2N plus 2. Okay, and this question tells us that that value is equal to 22. So we can use that information to solve for N. We know that 2N plus 2 is going to equal 22. 2N is going to equal 20. N is going to equal 10. So it should be C10 H22. All right, this is how you can use your general formulas to figure out information about your hydrocarbon formulas. Okay, so try to, hopefully you're able to figure those out. I would go back and practice if that still seems weird, difficult. You should also be able to name the following, okay? And you do this by looking at the types of bonds present and the number of carbons present. Okay, and just right off the bat, if this were me, I would be focusing on locating any multiple bonds first, right? So right over here, I see a double bond, so I know I'm going to need an ENE ending. In this example here, I see only single bonds, so I know I'll have an ANE ending. Over here, I see a triple bond, so I know I'll have a YNE ending. And then the beginning of my name is going to come from the number of carbons present. So take a second, get the answers in your head, pause it if you have to. Okay, this is what you should end up with. Propene, because there are 3 carbons, butane, because there are 4 carbons, and pentyne, because there are 5 carbons. Okay. For hydrocarbons that have functional groups attached, they're going to be similar but different, okay, because we have to indicate the type of functional group that's attached to our hydrocarbon, all right? Each functional group is going to have their own specific chemical properties that are going to be attached to them. It's going to change how the molecule behaves. The groups of organic compounds that all have the same functional groups are called a family of functional groups. Okay, and these are the main families. These are the ones that you are responsible for. All right, and it's less important, like the stuff that's over here. Like you don't have to memorize that stuff. Okay, what you want to know is stuff like an alcohol that has an OL ending, and an alcohol is going to have an OH functional group. An ether is going to have a carbon that has a single bond to an oxygen that has another single bond to a carbon. You see what I mean? An aldehyde would have an Al ending, and it would have a carbon that has a double bond to one oxygen and a single bond to another hydrogen. Right, these are you need to know very basic things about these functional groups. Okay, I'm not asking you to know what the chemical properties associated with each one is, but I want you to be able to look at a compound and be able to pick out the functional groups that are attached. Okay, and if it's something like a 3-carbon alcohol, I would want you to know that like that name was propanol, right? But you don't have to know the name of every alcohol that's present. You should be able to name the very basic ones. All right, so let's just take a little practice here. Pause this. Find as many functional groups as you can, okay? Don't just watch the answers pop up on the screen. Be a little bit active here. Okay, you're going to find the functional groups that are here and you're going to name them. Okay, we didn't actually talk about the methyl group over there, but anytime you see a CH3 that's attached to a carbon, that's called a methyl group. And you don't have to memorize that. That's just more for your own information. But I think that you should be able to see easily the alcohol group here the carboxylic acid groups that are here, the carbons that are double bonded to oxygens, and then single bonded to an OH group. Sometimes people confuse the carboxylic acid groups with alcohols because they see the OH, but you have to keep in mind that that OH is attached to a carbon that's also got a double bond to that oxygen. So when you see this extra piece of it present, that makes it a carboxylic acid, not just an alcohol. Okay. Over here, we have an ester. Okay, you could try these ones also. Again, pause it, try them. I'm going to put the answers up, but you should have tried them first. Okay, when you see a carbon ring, like what's present over here, at each juncture, so each point here, you're assuming that there's a carbon present here, okay? And you're assuming that they don't write the carbons in there, but you are assuming that there's carbons at every point of this ring, okay? So all those little intersections are carbons. And then hopefully with that in mind, picking out the functional groups after that is pretty straightforward. Okay. So again, that's just practice. Keep on practicing, keep on actively reading. This whole semester is in your hands now. You got this. Just make notes of anything that you're unsure about so that you can bring it up in recitation, so that you can bring it up with me on our meeting time on Wednesday. And just keep on plugging along.